Hello dear students, welcome to a new session. In this session we're going to learn about similarity. Similarity of two polygons. It is said that two polygons of the same number of sides are similar if the following two conditions are verified together. Their corresponding angles are equal in measure and their corresponding side lengths are proportional. This symbol is used to express similarity. According to the previous definition, if ABCD and XYZL are two polygons where the measure of angle A is equal to the measure of angle X, with the measure of angle B is equal to the measure of angle Y, the measure of angle C is equal to the measure of angle Z, and the measure of angle D is equal to the measure of angle L, and also the measure of the corresponding. So here, what you can see that is the measures of the corresponding angles are equal. The second part, that AB divided by XY, if you check the name up, it's ABCD and XYZL. So the same order, the first two letters over the first two letters, the second two letters over the second two letters, the last two letters over the last two letters, the first letter with the last letter over the first letter with the last letter, which is here AB over XY equals BC over YZ, CD over ZL equals dA over LX, which is equal to a constant. As you can see here, this represents what? That the length of the two corresponding sides are proportional. So we can say that from A and B, that polygon ABCD is similar to polygon XYZL. And take care, the order of writing the name is very important. Let's go now to remark number 1. In the two similar polygons P1 and P2, the constant ratio among the lengths of the corresponding sides of P1 and P2 is called the ratio of enlargement or the drawing scale. If the constant ratio is greater than 1, then the polygon P1 is an enlargement to the polygon P2. If the constant ratio is less than 1, then the polygon P1 is a minimizing of the polygon P2. If the constant ratio is equal to 1, then the polygon P1 is congruent to the polygon P2. Remark number 2. In order that two polygons are similar, the two conditions should be verified together, and verifying one of them only is not enough to be similar. Remark number 3. The congruent polygons are similar, but it's not necessary that the similar polygons are congruent. Remark number 4. All regular polygons of the same number of sides are similar. Remark number 5. If each of two polygons is similar to the third polygon, then they are all similar. Remark number 6. The order of corresponding vertices should be kept in giving names of similar polygons that to help us finding the proportional sides and the equal angles in measure. Let's now go to exercise number 1 to complete each of the following. If two polygons are similar, then the corresponding what are equal in measure? Excellent. The corresponding angles are equal in measure. Question 2. If the two polygons are similar, then the corresponding what are proportional? Good job. The corresponding sides are proportional. Question 3. If each of two polygons is similar to a third, then they are? Good job. They are similar. Question 4. If two polygons are similar and the ratio between the length of two corresponding sides is 3 to 4, then the ratio between their parameters is also the same, 3 to 4. So we can say that the ratio between the sides of similar polygons is the same as the ratio between the parameters of the similar polygons. Exercise number 2. In the opposite figure, the question wants me to find the length of xy, yz, and zl. As long as it's given that polygon ABCD is similar to polygon XYZL, again I told you before, take care of the order, right? So AB over XY is equal to BC over YZ is equal to CD over ZL is equal to AD over XL. So if you put the givens, you will see that AB is 10.5, so it's 10.5 over XY, which is unknown, equals 8 over YZ equals 5 over ZL equals AD, which is 6 over XL, which is 3. To find XY, we do cross multiplication. So XY is 10.5 multiplied by 3 over 6. If you do your calculations, it is 5.25. The YZ, it's 8 times 3 over 6, which is 4 centimeters. And also the ZL, it's 5 times 3 over 6, which is 2.5 centimeters long. Let's now go to the evaluation part. Dear students, I recommend that when you see the question, pause the video, try to answer the questions yourself, and then play the video again to check your answer. In this figure, ABCD is similar to XYZL. The first part, the question wants me to find the measure of angle BCD. The second part, the question wants me to calculate the length of XL and to determine the enlargement ratio. The third question, the question wants me to know what is the parameter of XYZL if the parameter of ABCD is 26 centimeters. Let's now go and solve number 1. Since the two polygons are similar, then the measure of angle D is equal to the measure of angle L, which is 80 degrees. So this D is 80 degrees. As long as ABCD is a quadrilateral, so we know that the measure of angle C or the measure of angle BCD is 360. Take away the sum of the 80 and the 125 and the 70. So the measure of angle BCD is 85 degrees. For question 2, as long as these two polygons are similar polygons, then XL over AD is equal to BC over YZ. If you substitute by values, you will see that XL, the unknown, over AD, which is 6, equals BC, which is 8, divided by YZ, which is 2.4, which is 10 over 3 if you want to simplify this ratio. So in this case, the scale factor is 10 over 3. So XL is 6 times 8 over 2.4. Then XL is 20 centimeters. And the enlargement ratio is 8. And the enlargement ratio is 10 over 3. So this one, we call it the scale factor, or we can call it the enlargement ratio. Question 3. We know that the perimeter of XYZL over the perimeter of ABCD, which is given as 26, is equal to the same as the scale factor, which is 10 over 3. Then the perimeter of XYZL is 10 times 26 over 3, which is 86 2/3 centimeters. At this point, dear students, we reached the end of our session. Thank you very much. Wishing you best of luck.